So all of today and tomorrow, we are going to work with quadratics that are in vertex form, okay? So this is what we call vertex form because we can look at it and without any math, we know where the vertex is, okay? What happens is this H and K, that's our vertex, okay? Our H is telling us how many we're going to move left or right, okay? And K is telling us how many we're going to move up or down, okay? And then A is the same A as what we talked about last week. A is either going to make our parabola skinnier or wider, okay? What we need to be able to do is we need to be able to pick out, hey, here's the vertex. And then we also need to be able to, from there, make a graph, okay? So let's talk about a couple of these. I want you to write down f of x equals x minus 2 squared plus 3. Okay, first of all, does this look like it's in vertex form? Does this have the same notation as that? Okay, it does, okay? I don't see an A. Is that okay? Yeah, that just means it's the same shape as our parent function y equals x squared, okay? It did not get skinnier. It did not get wider, okay? But this 2 and this 3 is affecting it, okay? Which direction is this minus 2 moving our parabola?
It's moving it left. It's moving it to the left 2.
I hear left 2 and I hear right 2.
It's left 2.
It's going to be right 2. Okay? So inside the parentheses, it's left and right, but unfortunately it's going to be backwards from what our brain wants. It's x minus h. So x minus 2 means we're moving in the positive direction. We're moving right 2. Okay? What about this plus 3? That's where our plus k is. What is that doing to our parabola? It's going to go up 3. Okay? So what we can do is we can say, oh, hey, our vertex is right 2 up 3. Our vertex is at 2, 3. Boom. Which means we also know where our axis of symmetry is. It's going to be at x equals 2, because that's where our vertex is. Okay. What I like to think about is since h is inside with the x is our left and right variable, right? So that's kind of where my brain goes. Okay. All right, let's talk about another one. How about g of x equals x plus 4 squared minus 2. All right, so this plus 4 inside with the x, which direction are we moving 4? Okay, we are going to move left 4. And what about this minus 2? Okay, which means we know that our vertex for this parabola is -4, -2, because we have to go left 4 and down 2 from normal. Okay, left 4 sends us to -4, down 2 sends us to -2. Okay. We also know that it's going to be the same width as y equals x squared. It's not skinnier, it's not wider. Okay. All right, so down at the bottom of the page, I would like you, is this like the bottom? Dang it. Okay, so on the bottom of this page, I want you to give me the vertex and the shape of number 5. And then I want you to turn the page and give me the vertex and the shape of number 7. Okay. I want you to do that with your elbow partner or as a whole table. Okay. Talk about it with somebody. I don't want it to be quiet. Do not multiply. There is no multiplying needed. Yay! All right. Emily, where's our vertex for number 5? Okay, our vertex is at 2, 0 because this minus 2 means we're going right 2, and then there's no plus k, which means we don't move up or down, so we just stay at 0. So 2, 0 is our vertex. Eva, what is this 5 doing to our parabola? It's making it what? Is it making it skinnier or wider? Yes. Okay, this 5 is making it skinnier. Okay. All right, number 7. Okay. Ava, where's our vertex? 1, 4. This means we move right 1. This means we move up 4. Okay. Now, what about the shape? Okay.
Well, since it's obviously less than 0,
Okay.
it's going to be mirrored or what?
Okay, so it's reflected.
Or mirror.
Okay, and then what is that 1/2 doing? Is it making it wider or skinnier?
It's making it wide.
Okay, so it's reflected, it's wider. Okay. And our axis of symmetry would be x equals 1. I sort of forgot about that little piece. Okay. Now, let's talk about what we need to do when we graph one of these. Okay. So we're going to come over here and we're going to graph number 9. Okay. So I would like you to make an XY table. Okay. We've always done that, right? We've always made an XY table. Now, Rachel, help me out. This plus 2 means we're going which direction to? Left 2. Do we go up or down any? No. So that means our vertex is at negative 2, 0 because we needed to go left 2. Okay. Do you see how I put a V next to my vertex?
Yeah.
Okay. So I know that that's where I need to have symmetry. So you know what I'm going to do? I'm going to choose numbers on either side of negative 2. And then negative 3, negative 4. I know that when I plug in negative 3 and negative 1, I should get the same y value. Okay? If I plug in negative 3 plus 2 squared times 3 gives us 3. Yeah.
What if we do it like, I know how you did it like that, but what if I do mine like 0, -1, -2, -3, -4?
I need the vertex in the middle.
No, I'm saying like -2, -1, then 0, and then
Oh.
-3, then -4. Does it matter which order?
No, as long as like negative 1 and negative 3 are next to negative 2. So we can see the symmetry. Okay, negative 1 plus 2 squared times 3.
3.
Okay. Not 0, 0.
2, and then square is 4. 12 is 12. 0 is 12. Is 12.
2 squared is 4 times 3 is 12. Do we agree? Well, I know you agree with yourself. Do you agree with Joey?
Yes.
Thank you.
Totally.
Okay, so we have negative 2, 0. Negative 1, 2, 3. I don't quite have enough room. Okay.
Imagine there's one where like an x minus 2 and then a minus 20 outside.
No? I actually really like graphing parabolas in this form because it's really quick to get the vertex. It's really quick to see if the shape is wide or skinny, upside down, whatever. But I think just getting the numbers that we need is a lot quicker than when we're in standard form and have to do negative b over 2a. Okay. All right, so let's graph one more together. What I want you to do is I just want you to cross this g of x out in number 11. And we're going to graph f of x. Okay, so I want everybody to just write down V for vertex and write down what you think the vertex is. All right, where's the vertex? Do you agree with -1, -1? Are we moving left 1, down 1? Okay, so then on either side of our vertex, we need to choose numbers to plug in. Okay, I'm going to give you a moment to plug those in. You're getting 2's for your -2 and 0? No? Okay, if we plug in 0, we would have 3 times 1 squared minus 1. Right? Which would be 3 times 1 minus 1. Okay. Now, I don't see anybody with their calculator particularly. It is okay to use your calculator. Let's talk about what happens when we plug in 1. We get 3 times 2 squared minus 1. We would get 11. I feel like this is a very similar graph to the one we just did, don't you? How did we know it was going to be so skinny?
Why is it 2? Because you minus the 1.
We have this minus 1 right here. Do you have a question?
No, I was yawning.
Okay.